All right, we're back here at the Denmark Drone Park. I'm going to open up QGroundControl before we do a test flight here in the iVue RC app, or the iVue RoboControl app in World's iVue. And we're going to reset the mLRS radio parameters for Develop Air. So we're going to keep the parameters as they are set specifically for this TX radio, but the RX radio inside Develop Air, we're going to reset back to the default. Which shouldn't be correct, but last time that we did not set up the parameters, we were able to fly Develop Air without the continuous rotation or yaw. So we're going to verify that is indeed the case today, see what information is not reported back properly, and see if there's any functionality that we're not getting if there's no parameters adjusted to what should be the correct parameters for said RX radio. All right. While we could do all these parameter changes over the radio connection, just since we're changing the radio parameters, we're going to hook up Develop Air to our computer via just good old-fashioned USB. Develop Air is now booting up.
Stabilize flight mode.
And we're just going to wait for it to connect. The vehicle configuration screen will open up here in just a moment once the connection has been established.
Pre-arm, battery 1 below minimum arming voltage.
And we're watching, and there we go. So now just going over to parameters, and I'm going to SR1, and I am going to change these back to the default. So let me do reset all to, no, I do not want to reset, load from file for review. And we're going to check the Develop Air base model parameters. Actually, from these Develop Air parameters 5125, I'm going to see if indeed these are different.
Battery 1 below minimum arming voltage.
So it has SR0 set instead. Let's see. SR0 extra 1 is set to 10. No, we don't want those. Load from file. We're going to check slightly older one. Here we go. So we just want all of these SR1 parameters, and you know what, we'll do the serial 1 options as well, but all of these we're going to uncheck and just select the serial 1 parameters. So these are the default values, as if you were just setting Develop Air up from scratch and you did not use our document to set the SR1 or serial 1 parameters. Reboot vehicle. Of course, QGroundControl is going to force quit or crash. Develop Air is still rebooted. I'm opening up QGroundControl manually, even though it'll give me a pop-up window here in a minute or two saying that QGroundControl crashed. You want to reopen? No, we already did that. All right. So we have satellite information reported back via USB. Now let's see, since we reset all of those serial 1 parameters, if that is indeed the case via the radio as well. All right, and then serial 1. All right. I think we should be good from a parameters perspective, so just going to unplug Develop Air from USB.
Communication.
We're gonna go set develop air out in the field. We're gonna open up QGroundControl just to see if we're getting any error warnings or messages, but we'll first attempt flight in the iVue RC app. If that does not work, we'll switch back to QGroundControl, see if we're achieving flight there, and then we'll see what happens next. Look at that, next to no issues putting on the props. It's almost like it's how it should be. All right. Leeroy Jenkins, let's do this. Let's hope that we have more than a 32.33% chance repeating, of course. Or repeating, of course, chance at success here. All right. And that message finally popped up like I mentioned. Let's go ahead and open up QGroundControl. It looks like we're ready to fly. What happens if we were to choose loiter flight mode?
Loiter flight mode.
All right, I think we're gonna be good. So closing out QGroundControl, opening up the iVue RC app, selecting connect to drone. We have all of our satellite information, battery percentage, voltage being reported. It's showing that we are in loiter flight mode. Now let's open up our console terminal window. Fly drone, arm and fly, initial takeoff altitude of 10 feet, clicking launch. And rotation. So either I overlooked some SR1 parameters that weren't set properly again, or reset to the proper position, or there is something else going on here. Well, let's land. Quite frankly, not really what I was expecting to see here today. All right, I'm not able to disarm here. I wonder if I can reboot while... Nope. Trying to see if I could reboot while armed, but that's actually pretty smart that it doesn't allow me to. Well, I guess I'm disconnecting from the iVue RC app and reopening QGroundControl back up.
Land flight mode.
We have to wait for all the parameters before we can disarm it. There we go. Finally just got the connection fully established. Now I should be able to disarm. Disarmed. Yeah. All right, so I'm gonna take off all the props. Gonna bring develop air back to me. I think what I'm going to do now is flash the firmware on both of these mLRS radios back to their default and just verify that all the parameters are actually back to square zero, I guess. And then if that seemingly doesn't work, to at least get no rotation in flight, that may be it here for the day, but another option is resetting all of the parameters on develop air manually. So let's see, I guess what happens next. Learning on the fly, quite literally. All right, so I am opening up the mLRS flasher. First, I'm going to start with this TX radio since it's already plugged in. First, I'm going to now unplug it. There are, I was going to say 2 buttons on this radio, but on the smaller MR22 version, this is the MR30, there's only the 1 button next to the USB-C port. Just hold that as you're plugging it in, already having the mLRS firmware page pulled up. And unless you want to hold this button down longer than what's absolutely necessary like I am, you're going to select the TX Maytech MR900 SICK to LEM option, which is the bottom option there. Hit connect and you'll see DFU in FS mode. We're going to hit connect and install mLRS. All right, we're just about there. All right. That radio is set up as if it were straight from the factory, just flashed and updated with the newest firmware. Now we're going to do the same with this radio. This has heat shrink on it, but is otherwise the same radio. And I know where the button position is, so I'm just going to hold that down even though you won't be able to see it. And I need to plug in a USB-C cable, which I'm just going to take the one here from our TX radio. Plugging our USB-C adapter, and don't do what I did. I just plugged it in before holding down the button. Again, you want to hold the button down as you're plugging in the radio via USB to your computer. Now that it's plugged in, I can let go. I'm just going to continue holding it until I select my option here, which is the RX Maytech MR900, the non-CAN version. We're just using a serial port. And hit connect. Again, select the FS mode option from the drop down. All right, so now we have 2 completely new setup mLRS radios, and let's just try them exactly as is with no new parameter changes. All right, Developer's top cover goes on nice and easily. TX radio is back on, not connected to developer as developer is not booted up. Grabbing the props and taking developer back out. All right, and here goes nothing. Well, hopefully something, but hopefully nothing in the form of no rotation. I'm going to refresh the iVue RoboControl app in World's iVue, but before I go back into there and attempt another flight, just going to see what information we're getting from QGroundControl. Still looks like we're going to be all right. Getting all the GPS and battery information. Not going to establish a full connection there. Already opened up the iVue RC app. And it looks like we're good there. Zooming in to developer's position on the map. Let's go ahead, fly drone, arm and fly. Launch to 10 feet. And still rotation. All right, land. And same thing. Wouldn't, ain't it lovely, ladies and gentlemen? Ladies and gentlebobs.
Landslide mode.
All right.
Disarmed.
All the props stay on that time? I looked down briefly. All right. So now I guess what's left to do out here as far as what I'm aware, other than asking for the help of more smart people like Ollie W over there on the mLRS development team, or leading the mLRS development team. Should be hearing from Mon on our team. I'm going to just reset all these developer parameters while we're out here, just to see if there's any other variable that could be causing this rotation outside of the mLRS radios, but seemingly it's only happening when these mLRS radios are being used with some improper configuration or setup. Give me something to... I'm taking off the props because we'll probably just want to do a quick motor test once all the parameters are set up, even though following our document we shouldn't need to do so, but you know, it can't hurt to really do a quick double check just to make sure all the motors are spinning the right direction. And as you could probably imagine, you don't want to do that with the prop still on unless you're meaning to fly. And just going to make the USB port a little bit more accessible. Bring over my adapter. Dead-ant. On our table. Oh, there's an alive ant too. Now there's 2 dead ants. Ant lives don't matter. You heard it here first, folks. Alright, now QGroundControl is going to be our friend.
Stabilize flight mode. Pre-arm. Battery 1 below minimum arming voltage.
Until it backtalks us, just like you heard. And then I'm going to the iVue Robotics website, scrolling down to Develop Air, accessing our handy dandy documents for the base XE and HP models. And then if you see this document here, we're just going to follow along after I reset the parameters to default, just going down the list. And so this is how, if you want to build your own Develop Air DIY, you would do so. But before I get too much further, I'm going to shut up QGroundControl. Just going to Application Settings, mute all audio output. All right. Then going back to Vehicle Configuration, Parameters, Tools, reset all to firmware defaults. Didn't get any sort of indication that it was working properly, but I rebooted and it should be very apparent upon reboot. Alright, it did go ahead and reset all the parameters. So starting out, you could see frame class 1, we're going to choose quad 1X. We're just going to use the user interface here instead of using the parameter screens, and we just took care of the first 2. Next, we're going to disable the safety switch. And, oops, misclick there. BRD _ safety default. And we're going to disable. Now, for any of the parameters that you see in this document that have parentheses, you could just use the drop down to select the equivalent of the numerical value. But if you want to set all these parameters by the numerical value, you have to hit advanced settings and manual entry for this to actually take effect. But you'll see me do that for some of these parameters and not the others. It's just habit at this point. So save on disabled. Now for the ESC, we're not using PWM control. We're using FETTEC's proprietary one-wire protocol. So we need to set that for the telemetry 3 port on the Pixhawk flight controller, which is serial 5. Serial 5 _ protocol. Here's where I'm going to, instead of scrolling down through the options, which you can do selecting FETTEC one wire, I'm just going to enter in manually 38, which you can then see populates as FETTEC one wire. And then serial 5 options is already set to 0, just want to ensure that's the case. Same thing with these next 2 parameters, motor, PWM min and max. Those are already set to 1000, 2000, just doesn't hurt to double check those. Motor spin min arm or motor spin min and motor spin arm, you do need to change. especially with the FetTech one wire, you can spin up these motors at a lot lower of a percentage than what you typically can using PWM. So motor spin arm needs to be set to 0.04. Again, manual entry I think is actually required here because the default values from the drop down actually don't go as low as what you can get with using this FetTech one wire protocol. All right, don't be alarmed that it says unknown. It does actually work properly, and you can see it actually rounds it to a weird non-0.04 value, and it does the same thing for the 0.07 set for the minimum spin speed. Minimum cinnamon spin. Tongue twisters. All right, 0.07. Establish correct motor order. So basically the layout of the FetTech ESC just has, I think it's motors 2 and 3 are swapped positions. So you'll see servo 1 underscore function is disabled. We're going to set that to motor 1, motor 2, motor 3, and motor 4 down that list. But if we actually reboot here, it should actually auto-populate now that we've actually set the frame and frame class and frame type. So by default, servo 1 will be 33, servo 2 will be 34, servo 3 will be 35, and servo 4 is 36. Again, we just need to swap 2 and 3. So again, QGroundControl crashes, force closes. At least it'll let you disarm develop air properly. So, you know, no software is made perfectly. At least none that we use. All right. So going back to the parameter screen, servo 1 function, you can see is motor 1, that's correct. Servo 2, like I said, we're actually changing that to motor 3. And before we reboot, we're just going to go ahead and change motor 3 to motor 2. And just to verify, so everyone that's watching can see, servo 4 is already set up to motor 4. All right, we could reboot then, but let's keep pressing onward just a little bit more, at least for another parameter. So servo FTW mask, if you select this, you could see what servos you're actually using. So basically another way of saying how many motors you're actually controlling with this FetTech one wire protocol. So we're going to select the first 4, and you can see it automatically sets the bit mask value to 15, or again, you could just let me move the window up, hit advanced settings, manual entry, and just typed in 15, and it would have selected those first 4 checkboxes for you. All right, and then now we need to reverse the direction of 2 motors. Typically with PWM driven motors, you can just change any 2 of the 3 motor wires that are plugged into the ESC, but you can't do that using the FetTech one wire protocol. You have to use this parameter. So let me go ahead and type servo FTW RV mask. It was already pulled up, didn't have to retype it. And then again, I can just set that to 12, and because it may not be as apparent depending on how closely you follow along in building develop air, if you need to switch other motor directions, again, you can see it auto selects the checkboxes 3 and 4 when we did the manual entry, entering in 12 as the bit mask number. All right, let's go ahead and reboot, even though it's not really strictly needed now. As you do this more, you'll get a sense of where it's helpful to reboot and not. And again, typically I wouldn't, but hopefully this is helpful for a lot of newcomers, even beyond develop air, just people getting into Arducopter drones, or especially those with the components that we use or similar components. All right, configure parameters. First, we're going to start with battery failsafe parameters here. So bat underscore failsafe, or FS, crit action. We're going to tell developer to land if the battery gets critically low. If the battery just gets low but not critically low, it's going to smart RTL or RTL. That's the return to the launch location or the home location. And then smart RTL is following the path that it took, or a path, safe path that it took to get back home, instead of just trying to fly straight there by the quickest means necessary. FS throttle enable, we're disabling. And that's basically if there's no throttle detected, that developer will continue operating. FS GCS enable. That's again if there's no ground control station disconnected. So like when we closed out of the iVue RC app and switch over to QGroundControl, we want developer to keep operating and not necessarily return to land or return to the launch location. So actually, that's exactly what we want here, is smart RTL or land. So if you do lose connection to your ground control software for a period of more than 3 seconds, as seen in the next parameter we set, developer will return to the launch location via smart RTL, or just land wherever it is if that's not possible. And then we're going to change the arming checks to disable the RC and parameters checks that it does, but keeping all of the others. This you'll definitely want to set manually and not do the checkbox entry. But if you decide to do that, have fun doing so. You're kind of on your own there. 65470 and save. All right, and then lastly here, as part of this section, RC options we're setting to 0. And this should properly allow us to fly developer without any sort of controller connected. But as you can see, we're not getting that with the continuous rotation. And from some of our last test flights, when you plug in a controller, or even before you plug in a controller, but switching over to loiter flight mode to be able to fly with a controller, we're seeing developer lose throttle. So set RC options to 0, and then here is just a kind of safety feature, if you will, setting the RTL altitude to 150 feet in centimeters, or 4,572 centimeters. So if developer goes into RTL mode, it climbs up to 150 feet before coming home, and it should avoid any obstacles between, or most obstacles between you and wherever it is at that point. Land speed, we're just slowing that down to the minimum value of 30 centimeters per second. And this next parameter, since we use lithium-ion batteries, they're more prone to what's called voltage sag, and we're just trying to get a better voltage readout when developer is operating in flight. Instead of reading a raw voltage value, it tries to compensate for the voltage that's actually being used, or the power that's actively being used in flight. And that's of course going to report a lower voltage number than if you were to land developer. You'll see the voltage number climb back up, indicating that you still have quite a bit of battery life. And now we're going to enable power monitoring via the power monitor board that we have plugged in via I2C, or the I2C port on the Pixhawk. So battery monitor, I'm just going to select from the drop down, but again, you can enter in 21 using the manual entry option, and here you'll see that you need to reboot. So let's go ahead and reboot. And you actually do need a reboot there, even in other times where you get that pop up. Not every time it's actually critical, but that battery I2C bus parameter would not even show up until a reboot occurred. So battery I2C bus is set to 2. And we need to reboot again. Before we do that, we are just going to enable the Lua script. This Lua script runs the battery status and position lights on Develop Air. For now, that is being changed. And then once we're rebooting, then we're going to set it up, Develop Air up to understand what battery's connected to it. Parameters, bat capacity, 8,000 milliamp hours. All right, battery low milliamp hours. So this information is used to trigger the fail safes that we had set earlier. Critical milliamp hours, 1,222. Battery low voltage, 14. Battery critical voltage, 13.33. Battery low timer, 8 seconds. And that's just to make it so Develop Air will start its fail-safe actions a little bit sooner than it otherwise would, a couple seconds to be precise. Battery arm voltage set to 14, and that's just, as it implies, the minimum voltage the battery connected to Develop Air needs to be at for you to fly. You can set that lower, but for most operations you're going to want more battery than not. So this is just when you have a controller plugged in, this pilot Y rate parameter is to adjust if you're rotating Develop Air with a controller like so, just how quickly it's making that rotation in degrees per second. 60 degrees per second I think is good for almost everyone that's not a boomer that needs it to be like nice and real slow like. So those are all the parameters that we should need to set for the base model Develop Air, other than the mLRS radio parameters, which we mentioned we're not going to set just for a matter of troubleshooting and trying to eliminate all variables in said troubleshooting. So now that all the parameters are reset, going to reboot once more. We're going to reopen QGroundControl before switching back over to the iVue RC app. And we are going to make sure just all the motors are spinning in the correct direction. We did get an error message about the Lua script, but that could very well be because the battery's not plugged in. Let's see when we plug in the battery if all the lights come on as they should. I think I might have skipped a parameter. If I go to servo 9, I think we're going to see, yeah, I did not actually set that properly. So we're going to do advanced settings, manual entry, set it to 94 or script 1 from the drop down. There's just, again, a lot of options in that drop down. Going to reboot vehicle, reopen. And do we have lights? Nope, not yet. And we have lights. Okay, so don't do what I did. Actually double check that all the parameters are set as is. Again, just after that reboot of the SCR enable parameter, I forgot to go back and set the servo 9 function parameter to 94 or script 1. All right, so now that we're back in QGroundControl, we're going to go to the motors tab. We're going to set the throttle to like 8%. Start with motor A. All of the motors should be spinning inwards. So if you're looking at Develop Air, This is the inside, right, between the motors. So motor A spinning inside to the middle of develop air. Motor B spinning to the inside, the middle of develop air. Motor C spinning to the inside of develop air. And motor D spinning to the inside of develop air. So we should at least be able to get flight, hopefully rotation-free flight, but let's disconnect from QGroundControl. Actually, since we did just reset everything, what I always like to forget, not what I like to forget, but seemingly forget, is redoing the accelerometer and compass calibration. So we can do the accelerometer calibration here via the radio. Of course, QGroundControl just crashed because, again, it's just such great free open source software. And we're just waiting for a QGroundControl to finish establishing a connection. It'll automatically open up the vehicle configuration screen again, and then we'll proceed with the accelerometer calibration. Do 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 do. All right. And now for Final Jeopardy, the accelerometer calibration. So you just have to follow along with the graphics. It's asking you to hold still with develop air flat and level, or your aircraft flat and level. Now it's asking you to put it on the left-hand side. We're just going to hold it still, stable, still, steady. One of those 3 S words. And then again on the other side, the right side. And then nose down. And now nose up. And now upside down. All right. Gonna hit OK. And we're gonna go to parameters, tools, reboot, watch QGroundControl crash again. And now we're gonna go set develop air away from all of our devices that could interfere with the compass. Probably here's about good. And let's go ahead and get the compass calibration screen pulled up. And we're gonna watch me do the best compass calibration dance I could do. All right, so develop air just made a beeping noise indicating it's ready. Just picking develop air up and rotating it as smoothly as possible, trying to basically pretend develop air is in the middle of a sphere and you're trying to touch all of the points on the inner side of the sphere. May not be the best visual description. And let's see just how awfully I did for that compass calibration. Dun 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 dun. One in the yellow, one in the red. Brian, you want to give it the good old compass calibration dance? Show me how it's done. Yeah. If you, the viewer, are not as incompetent as I am, you too can be like Brian and do seemingly almost the same thing, but just have it work. Yep. So without me having to cue him, Brian was able to know it was ready based off of the beep. All right, we're about 3/4 of the way through, almost there. And yeah, one in the green, one in the very upper end of the yellow. So look at that, folks. Some people just have it, others don't. All right, doing a reboot and gonna put the props back on now that we have Master Compass Calibration Dancer Brian on our side. All right, look at that. You guys are getting a special treat after that quickie you had on our last attempt out at the field. All right, QGroundControl looks good. We're gonna open up the iVue RC app and hopefully achieve rotationless flight. Hopefully. I got ants in my pants. No, that's squirrels in my pants, I think. Phineas and Ferb reference for anyone who's anyone. There's 104 days of summer vacation, but school comes along just to end it. And that's about all I know. Finding a good way to spend it. Like building a drone and troubleshooting them, 'cause they don't work all the time. Dun dun dun. All right. Are we gonna get lucky today? No. All right. We are in, ladies and gentlemen. I'm just going to refresh completely though. Because yeah, we're definitely not getting like the UI working as it should. That should show us that developers in loiter flight mode. So, and now we're not getting satellite battery information, voltage information. I wonder if I reset permissions for the mLRS radio, if that still proves to be the case. That is still the case. All right, but I think we should still be good. We're going to attempt a test flight here in the iVue RC app, even though we don't have access to all the information to show that it should still fly properly. And then regardless of the outcome, we're going to switch back over to QGroundControl, see if we get the information back. If we do, we're going to switch back to the iVue RC app and attempt another test flight. So flying drone, arm and fly, take off. Nope. Drone successfully armed, drone not connected. Okay, so yep, no, definitely a problem there. Try fly, arm. Drone not connected. All right, I'm closing out of the iVue RC app again entirely. Reopening up a new window. Resetting permissions. And if it doesn't work on this attempt, we're gonna go QGroundControl. All right, so now we're getting satellite information, battery percentage, voltage information. We're getting the UI working properly, so this is boding pretty well. Hit fly drone, arm and fly, launch drone. And rotation. WTF. Fuck that prop. We didn't want you anyway. All right. Disconnecting from the iVue RC app. Still kind of at a loss because this is all the same hardware that we used if you watched our MTSU demo video. Same developer, and we were not having these same problems. Had different problems out there, but again, all seemingly tied to these mLRS radios. At least it disarmed properly this time. But yeah, that might be it here out at the drone park today. So stay tuned next time, and hopefully we'll have a non-rotating developer to show you. But if not, you'll catch us out here nonetheless. Thanks for watching.